All right, so today I will be going over the medication Lovastatin. I'll be starting off with the cholesterol synthesis pathway, which is the pathway that lovastatin affects. So first you start off with a molecule of HMG-SCoA, and this has a CoA group on it, which is then reduced into an alcohol forming mevalonate, and this is done by HMG-CoA reductase. You then have mevalonate being converted into phosphomevalonate with the addition of a phosphate group through mevalonate 5-phosphotransferase. Phosphomevalonate is then another phosphate group is then added to phosphomevalonate through phosphomevalonate kinase, and that forms 5-pyrophosphomevalonate. 5-pyrophosphomevalonate is then converted into isopentenyl pyrophosphate, and this is actually an ATP-dependent decarboxylation reaction, and a temporary intermediate is formed, which gives off a phosphate group as well as carbon dioxide. Isopentenyl pyrophosphate is then rearranged into dimethylallyl pyrophosphate, and this is really just the rearrangement of a hydrogen atom. Excuse me. We then have a molecule of dimethylallyl pyrophosphate being added with isopentenyl pyrophosphate, and this forms a 10-carbon molecule of geranyl pyrophosphate. And this is done through a head-to-tail condensation reaction using the enzyme prenyltransferase. We then have geranyl pyrophosphate being added with isopentenyl pyrophosphate, and this forms farnesyl pyrophosphate, which is a 15-carbon molecule. And this is another head-to-tail condensation reaction. We then have two molecules of farnesyl pyrophosphate being added together in yet another head-to-tail condensation reaction to form a 30-carbon molecule of squalene, and this is done through catalyzed by squalene synthase. Squalene is then converted into 2,3-oxidosqualene with the addition of an epoxide ring. And this is catalyzed by squalene epoxidase. 2,3-oxidosqualene is then converted into lanosterol, which is the first steroid molecule and yields the classic steroid ring. Lanosterol is then converted into cholesterol through a 19-step process. And in short, it's really just 3 methyl groups lost, as well as a double bond lost, and this double bond is then rearranged. So moving on to lovastatin, it's a cholesterol reduction medication that was discovered in the late 1970s, and about 10 years later, it became the first FDA-approved statin on the market. It's actually fungally derived, as it is naturally occurring in certain species of fungi, and it is classified as an HMG-CoA reductase inhibitor, which we will now get into. So, regarding the mechanism of action of lovastatin, as I just mentioned, it is a HMG-CoA reductase inhibitor, and it's a competitive inhibitor, meaning it binds to the active site of HMG-CoA reductase, which is the enzyme needed to catalyze HMG-SCoA into mevalonate. So essentially, this prevents HMG-CoA conversion into mevalonate, and subsequently, the remaining steps of the cholesterol synthesis pathway do not occur, leading to a reduction of your cholesterol, of your LDL cholesterol. Now, it is important to note that lovastatin is lovastatin is a prodrug, so it is first administered as an inactive lactone, And when it passes through the liver, it is then converted into lovastatin hydroxy acid. And basically, this carbon ring opens up here, making it into its active acid form. And as I just mentioned, this metabolism occurs primarily in the liver, which is also where the cholesterol synthesis pathway occurs. So this actually takes advantage of first pass metabolism through providing a large concentration of the active acid form of lovastatin, which will strongly inhibit the cholesterol pathway within the liver.